intro to series, and it's just a little new. It's not super new. And so a series is where I find the sum of the terms sequence. So we learned about sequences, arithmetic, and geometric sequences. And a series is when I take those numbers that are in the list and add them together. Sum means to add. So let's look here at this first sequence. Is this arithmetic or geometric? Arithmetic, because it's adding 1 each time. And so to turn that into a series, I will do 1 plus 2 plus 3 plus 4. And what do I get? 10. What about the second sequence? It's almost identical, but what's the difference? It continues, the dot, dot, dot. So this would be 1 plus 2 plus 3 plus 4, and I would keep adding literally forever. So can I get an actual number as my sum? No. Any way that we can write that, maybe? Infinity, yep. And we'll come back to that. Sure. You can turn it sideways and draw an 8. Okay. What about this sequence? Is it arithmetic or geometric? Geometric, because to get from one term to the next, I am multiplying by 2. So to turn it into a series, I would put 3 plus 6 plus 12 plus 24.
We add even when we have 45.
You get 45. So a lot of people see that is geometric, and they get confused when I put plus signs between them. No matter what type of pattern it is, a series means I still add the numbers together. But to get from one number to figure out what the next number is, I'm multiplying by 2. So what would I add to 24 next? 48. So I would, if I kept going,
it doesn't mean anything.
Siri keeps going off. So I would do plus 48, and then I could keep going. But you still technically add the numbers together. But to know what's the next number to write, it's being multiplied. It is confusing. So most of our sequences technically go on forever, and we would always have infinity on those. And so to fix that, so we just don't write infinity every single time, we do what we call partial sums. And that just means I'm taking this sequence, but I'm saying we're only going to find the sum of part of it. And so you'll see a big S with some number down in the corner. So if you see a big S with a little number, that means that you're finding the sum. So let's look at number 1, and I'm asking you to find S9, which means the sum of the first 9 terms. How many terms did I give you? 5. Can you figure out what the next 4 are?
Yeah.
Yes.
Yeah, pretty easy, right? So let's do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Yep.
Is there a way to abbreviate
You could like do plus 3, and then you could do like ... plus 9 to show that you went up to 9. That's fine. What do we get? 45 is correct. So the sum of the first 9 terms is 45. Let's just do one more of these. Let's just go down to number 4. And I want to find the sum of the first 6 terms. So that would be 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5. That's only 5. What would be my 6th one? 1/6. Yeah. And now type all of that into your calculator.
Well, that's easy.
Oops. That's a lot of typing fractions. And you should get 49 over 20. So that would be really frustrating if I ask you to find the sum of the first like 30 terms, right? That would take a really long time.
But you would never do that.
I would not. Well, I will do that, but I would not make you manually type it in. This is where this next thing comes in. So, anybody know what this symbol represents?
No.
Sigma.
Sigma.
This is sigma. Right there. And sigma means the sum. It's a way to represent the sum of several numbers in a pattern. And so when we do sigma, there's several things that we have to put in the calculator. The first one is this on the bottom. And for what we do, it's pretty much always going to be n equals 1. So that bottom part is where we start adding. And so we're always going to include the first term when we add. So this means I'm going to start adding at term number 1, at A1. And up top is where we end. So I'm going to stop adding For what we're doing today, I'm actually going to give you the formula. What we're going to do in the next few lessons is you're going to come up with the formula yourself, which is exactly what we were doing in the last few lessons. Those AN formulas that we did, that's what's going to go over here. So, in the calculator, we're just going to do a few of these examples. I was originally going to do them by hand, then I changed my mind. So, in the calculator, click Math, 0. You can hit the 0 key or you can scroll down to the 0 and hit Enter. But Math, 0. We'll pull this up.
Oh, that's weird.
And then we have to tell the calculator what to type in. You'll notice here that we have an N And you can definitely use the n, but you can also just use x. It's easier to do that. So if you do x, it takes you over to the next box where I'm going to type in a 1. And then I'm going to go up to the top and type in a 4. And then I hit the right arrow and type in x minus 1.
6.
And I get 6.
Easy peasy.
Yep.
Women's.
Okay.
Math.
You got x equals 1 on bottom,
Yeah.
4 on top.
No.
Now, boy.
Yes.
So if we wanted to show our work for like one of these questions, we just like draw this out on the paper, right?
Yeah. All right, next question. Math 0. X equals 1 to 5. And then negative 3x.
This is easy peasy.
It is. Equals negative 45. Do you want to see some more examples? Or are we just ready to practice? We'll stop there and practice.